Now next question is integration of secant square x times cosec square x dx. So for this, how we can solve this kind of questions? First, we have a formula sec x can be written as 1 by cos x. So what we will do here, we will write as it is, integration as it is, 1 upon 1 r over cos square x. Then cosec can be written as 1 divided by sine square x dx. In the next step, we will write integration. If we multiply these two, it will be simply sine square x cos square x. Now, and in the numerator, it will be only 1 dx. In the next step, 1 can be written as sine square x plus cos square x. So, in place of 1, we will write sine square x plus cos square x, in denominator sine square x cos square x. At the end we have dx and here integration. Now if we separate this part, sine square x by this and cos square x by this, in the next step we can get integration, this integration part and this is the trigonometrical part. We will write here sine square x over sine square x cos square x plus, we have again cos square x divided by sine square x cos square x. Then at the end we have dx. Then we can simply cancel here sine square x, from here cos square x, Now in the next step we can write integration of 1 by cos square x, 1 by cos square x dx plus integration of 1 by sine square x dx. Then if we simplify further, 1 by cos means secant x. So we can write simply integration of secant square x dx plus 1 by sine means cosec square x. So integration of cosecant square x dx. Now if you remember, we have formula integration of secant square x dx equals to tan x, and integration of cosec square x dx equals to minus cot x, and both we have integral constant plus c. Let's put this in the rectangle. Now based on this formula, we will write sec square x dx means tan x, and integration of cosec square x dx minus cot x plus integral constant. This is your final answer. Our next question is integration of 1 plus sine square x over 1 plus cos 2x dx. Here in this, if you remember, we have one beautiful formula, that is cos 2x equals to 2 cos square x minus 1. If we simplify this, we can get cos 2x. This minus 1, if I shift to here, it will be plus 1. Then the remaining will be 2 cos square x. We will now use this formula over here. Now we will write integration. We will write the same thing here. 1 plus sine square x upon, now in place of 1 plus cos 2x, we can write 2 cos square x dx. Now here we will, since we have addition plus here in the numerator, so we can make the parts, we can separate it. We can write here integration of, now we can write 1 by 1 upon 2 cos square x, plus is here, so plus, and sin square x by cos square x, sin square x upon cos square x at the end dx. Now we can apply integration to this part and also to this part, or we can simplify further. Integration cos square x can be written as secant square x. Cos square x can be written as secant square x. One thing here, we missed 2 here. This 2 also have to come here. Now, from this, we will take out 1 by 2 is constant. So we can write 1 by 2 outside. Then integration, we can write secant square x. Then plus, from here 2 is already out. We can write sin by cos, we can write tan square x. Then dx. In the next step, we can write 1 by 2, we can write integration secant square x, tan square x can be written as secant square x minus 1. So just what we are changing here, in place of tan square x, we are writing here secant square x minus 1. Now, then dx. Secant square x plus secant square x, it will be 1 by 2 integration of 2 secant square x minus 1 dx. Now we have solved the trigonometrical part. Now we can apply the integration here. Now we can write 1 by 2 integration of secant square x, that is what, tan x. So 2 is as it is. From here we will write 2. Here integration of secant square x tan x minus integration of 1, that will be x. Then plus c, integral constant. This is your final answer. Then we can add final c, integral constant.